Hello and good afternoon. Today I'm going to be introducing myself. My name is Kaaviyan. For our core subject ECV 3213, we conducted a group project on structure analysis of building using a software for a 2D and 3D model. So I'll straight away start with the introduction. In this project, our client requested, based on the question given to us, the client requested a report on an very extensive analysis of the building based on various Euro codes of provision and a load combination of different several subframe analysis. For this project, we decided to use two.
So we are gonna show on how we did our manual calculation. So before that we need to determine our slab system, which our slab system is we use formula for the longer span over the smaller span, which is the longer one is 9 meter, the smaller one is 4 meter, and the ratio give us value more than 2, which our slab system is one way slab. So it shows that only the girder, the long span, will carry the load. The short one, the 4 meter, will not carry any load. So we calculate the area load by using Euro code, multiplying the factor of safety 1.35 multiply with the dead load and plus with 1.5 of effective safety time with lift load. So it will give us a total uniform load area. So this is how much the outer part carry. Meanwhile, the inner part of the beam, it carry twice the load carry by the outer part. The distance here is 2. Meanwhile, the distance for we are gonna analyze our structure by using moment distribution method. So before that, we need to know the value for fixed end moment, which we calculate using formula WL squared over 12, and we also need to know the second moment area for the beam and for the column. This is calculation part. So next we calculate the stiffness, the horizontal stiffness member and the vertical member stiffness, because they have the same length. So the stiffness for vertical for the tree will be the same, and the horizontal will be the same for the AB member and BC member. So we calculate the total stiffness at the joint, which the L shape total stiffness at point A and point C. We just add the horizontal stiffness and the vertical stiffness. Meanwhile, the total stiffness at point B, we sum up the two of the stiffness AB, BC, and one vertical stiffness member, which is BE. Then we construct the moment distribution method table. So we iteratively until the value diminish until 0. Next, we calculate duration on the member, and before that I forget to tell that this calculation part is for the out outer frame, which is it can be either AA cross section or KK cross section. Here it can be either A or K. So here the shear force diagram and bending moment diagram. Here the shape. Same to the ground floor, we construct the table, we calculate direction, and here is the shape for the shear force diagram and bending moment diagram.
Okay, next, my name is NAZURAH BINTI NAZLI. My matric number is 198076. I will show you about the 2D software analysis, structure analysis software, which is LIMPRO. So this is the reaction, the result of reaction after we apply the distribution load. Then next, this is the deflection shape. As you can see in this, let me zoom in so more clear. That's so you can see the value of deflection shape. Next is the shear force diagram. You can see the values of shear force diagram. So 64. This is the ground floor, first floor, second floor, and third floor, fourth floor, and this is the what we call the top floor. So next, the bending moment diagram. The bending moment diagram, we use this result to compare to. This is the result is important because we compare to the 3D and we compare to the hand calculation. We use the bending moment diagram. So
Okay, so now I will explain about the second software, which is SAP 2000. So SAP 2000 is a well-known structural analysis software, especially to analyze the 3D model. The compact model can be generated and meshed with powerful templates. The integrated design code, which you can automatically generate using the design code, checked per US, Canadian, and international design standard. So, okay, this is the model that our group been generate, which is it has 6 story with height of 3.6 meter. Also in the x direction, the bay is 10 with the width 4 meter, and for the y direction, we have 2 bays with 9 meter width. So for overall, the height for the structure building is 18 meter. So for the result, based on after we run the analysis in the SAP 2000, so for the reaction, it have the moment with 27.88, which is quite similar with what we got in LIMPRO, and also the deflected shape is quite similar too. And then for the shear force diagram, the SAP 2000 have analysis the SFD for the beam for each floor and with the value. Also, like this for the bending moment diagram, the software will run the analysis and show each part of the value with the maximum bending moment. For this part with the red side, this one is the bending moment, maximum bending moment for each floor. So for the comparison between of the maximum bending moment for each method that we use in this project to analyze the building. We have hand calculation, we have 2D structural analysis software, which we use the LinkPro, and also the 3D structural analysis software, which is the SAP 2000. So we have done for two level, which is roof and ground floor, and this is the result. After we got each result for maximum bending moment, we have calculated for the percentage error. The percentage error is quite inconsistency when using these three methods being compared. The difference of the percentage error for the roof and ground floor are more than 10%. However, for the 2D and 3D analysis results are almost 85% the same. This difference might be occurred due to the limitation and consideration of few parameters such as material that been proposed by the client, but it cannot be assigned or cannot be run by the 2D software LinkPro. So yeah, that's why it might be a little bit different.
Like 85% of the 2D structural analysis software and the 3D structural analysis software is the same. There is the slightly different because some of the limitation that have been noted during the handling LinkPro and SAP software, which is the LinkPro software have limitation on adding some parameters such as material used in the structure, while SAP 2000 software has limitation where the some parameters does not exist in the manual two-dimension analysis in of the data taken from the LinkPro. This might be some reason why the result both software is slightly or quietly different. As a conclusion, like the objective, we as an engineer need to make a decision which is from the analysis structure. We need to make a decision which the software the best for our project. That's all from us. Thank you.